Hello everyone. By now, hopefully I have a baby, and so I'll be taking my paternity leave, and I will be doing videos of each lesson so that we can stay on pace, and keep up with where we should be in the textbook. So we're starting here in Chapter 4, and Chapter 4 is all about writing functions. Chapter 3 was about graphing functions. Now we're going to go the other way. We're going to be given graphs, and we're going to write functions for those graphs. So first of all, just remember the most common one, the one that students like the most as far as forms would be slope-intercept form, where we had y equals mx plus b, where m stood for the slope. Remember, it was pretty easy to find the slope as long as you knew the slope formula. Y2 minus y1 over x2 minus x1. And then b stood for the y-intercept, where the graph crossed the y-axis. And x and y wound up being any coordinate along that line. And so today, our objective would be to write equations in slope-intercept form given some information. So first of all, example 1, write an equation of the line with a slope of 4 and a y-intercept of 3. This would be the most basic type of question, because they give you all the information that you need. If we know that the slope is 4 and the y-intercept is negative 3, well then we simply just need to plug this into that form. Y equals mx plus b. And so our final answer just here would be y equals 4x minus 3. Not a problem, as long as you understand what slope and y-intercept are and where they go in slope-intercept form. Okay, moving on to a slightly more complex version of the problem. Example 2 says write an equation for the line. And so here we have to do a little more digging for where we're going to get our slope and our y-intercept. Although it is pretty easy to see here that the y-intercept is at 2. We can say b equals positive 2, but then the slope, well, we could either count, it'd be kind of difficult on this graph to count, or we could use the slope formula, which I think we should probably do since what we've been given is 2 coordinates. And so what we have here is 0, 2, and 4, negative 1. If I'm going to use the slope formula, I'll just say 2 minus negative 1, y2 minus y1, over 0 minus 4, x2 minus x1. This would leave me with 3 over negative 4. It's a negative slope, and you can see right there it's a negative line. And so we've got this here. Slope is 3 over negative 4. My final answer would be y equals negative 3/4 x plus 2. Notice that here I've got the negative sign down there, here are the negative signs up there. Does it really matter? The answer is no. Negative 3/4 is the same as negative 3 over positive 4. All right, example 3. It says write an equation for the linear function f with the values f of 0 equals 3 and f of negative 4 equals 11. Well, in chapter 3 we learned a little bit about function notation. We understood that, remember, f of x looked like this, and basically whatever was inside here for x was what x equaled. And f of x essentially equals y. And so if I have f of 0 equals 3, that means when x equals 0, y equals 3. Here, if f of negative 4 equals 11, that means f of, or I guess when x equals negative 4, then y equals 11. I can turn this into the coordinate, or the 2 coordinates, 0, 3, and negative 4, 11. And now, this winds up not being a whole lot different than this one. simply because one of my coordinates is going to give me the y-intercept. If I were to graph it out, you could see, the y-intercept would be here at positive 3. And so we'll say, all right, the y-intercept is 3. The slope, well, I'd probably have to use the slope formula again for this one. 11 minus 3 over negative 4 minus 0 would give me 8 over negative 4 for a slope of negative 2. To put this all together in my function, I'm just going to say y equals negative 2 times x plus 3, and that would be the function for these two coordinates given in function notation. Okay, that's it for lesson 1. Have a good day.